A modern container ship can carry more than 20,000 containers, weighs over 200,000 tons, and connects entire continents. Yet, it moves slower than a city bicycle. This is not a technological failure. It's not outdated engineering. And it's definitely not because shipbuilders can't make ships faster. Ships are slow by design, and today you're going to see exactly why. In this video, we'll break down the physics, economics, fuel dynamics, structural limits, and global regulations that intentionally keep ships slow. By the end, you'll understand why increasing speed by just a few knots can double fuel costs, and why the fastest ship is often the least profitable one.
The first reason ships are slow is simple: scale. A cargo ship is not just big, it's operating at a scale where physics behaves differently. Doubling the length of a ship doesn't double its mass, it increases displacement exponentially. Every additional ton pushes more water aside, increasing resistance, and water resistance grows far faster than air resistance. Unlike airplanes, ships must constantly fight the medium they move through.
Ships face three main types of resistance: frictional resistance from water sliding along the hull, wave-making resistance as the ship pushes water forward, viscous pressure drag behind the vessel. Here's the critical detail. Wave resistance explodes near hull speed. Hull speed is the theoretical maximum speed before the ship begins climbing its own bow wave, and for large ships, this limit arrives surprisingly early. Pushing past it requires exponentially more power.
Naval engineers live by a brutal rule. Power required increases roughly with the cube of speed. Increase speed by 10%, fuel consumption rises by 33% or more. Increase speed by 20%, fuel usage can jump over 70%. This is why a ship cruising at 22 knots may burn nearly double the fuel of the same ship at 18 knots for only marginal time savings.
Fuel isn't just expensive, it's everything. For most cargo ships, fuel accounts for 40 to 60% of operating costs. At scale, saving fuel by reducing speed isn't optimization, it's survival. This is why the industry adopted slow steaming after fuel prices spiked in the late 2000s. Ships didn't get slower because technology failed. They got slower because accountants won. Marine engines are not designed for sprinting. They are optimized for long-duration, steady-state operation, running for weeks without stopping. Operating them at higher RPMs drastically increases wear, maintenance intervals, and failure risk. Ships are designed to cruise where engines are most efficient, not where they are fastest. Speed doesn't just affect fuel, it affects the ship itself. Higher speeds increase hull bending moments, slamming forces in waves, fatigue on welds and frames. At sea, speed amplifies wave impact forces dramatically. A faster ship doesn't just move quicker, it ages faster. There's another hidden bottleneck: ports. A ship arriving early doesn't unload early, it waits. Berths, cranes, labor schedules all operate on fixed windows. Arriving faster often means burning fuel just to anchor and idle. Speed without port synchronization is wasted speed. Modern shipping is governed by emissions rules. Organizations like the IMO now enforce strict limits on CO2 output, sulfur emissions, fuel efficiency per ton-mile. Higher speed almost always violates efficiency targets. Slower ships aren't just cheaper, they're legally safer. Could we build faster cargo ships? Absolutely. But faster ships require more powerful engines, stronger hulls, more fuel storage, higher operating costs, lower cargo efficiency. In shipping, speed is not the goal. Reliability per dollar is.
Warships break these rules and pay the price. They burn fuel aggressively, They require constant maintenance. They trade efficiency for tactical speed. Civilian shipping cannot afford this model.
Shipping isn't measured in speed. It's measured in ton-miles per unit of fuel. A slow ship moving massive cargo efficiently beats a fast ship moving less every single time. This is why the slowest vessels often generate the highest profits.
New technologies may change the equation. Wind-assisted propulsion, advanced hull coatings, hybrid engines, AI route optimization. But even with innovation, the core truth remains: water resistance punishes speed.
Ships aren't slow because engineers lack imagination. They're slow because physics, economics, and logistics demand it. Every knot faster costs exponentially more in fuel, stress, emissions, and money. In global shipping, the smartest ship isn't the fastest one. It's the one that arrives on time, intact, and profitable. And that's why ships are slow, by design.